Okay, and what kind of situation we had in grade 11? To find normal force, to find force of gravity. So if object is not pushed by any forces, so force of gravity equal and opposite to normal force. Okay, F normal and N or N, so it doesn't matter how you call it, Fn or normal. So they equal and opposite. Okay, so if you have mass of the object, for example, 5 kilograms, and we can count G equal 10 newtons per kilogram, or meter per second squared, the same. So how to get force of gravity? Mass multiplied by acceleration of free fall. So 5 multiplied by 10, so 50 newtons. So force down is 50 newtons, and force up is force of reaction, the same. So just opposite direction, the same magnitude. So what will happen if you push or pull on the object? So if you push with force applied 10 newtons, so your force of gravity is the same. It doesn't change because it depends only from the mass of the object. But you have also this applied force in the same direction down. So normal force, its force of reaction from the surface will be 50 plus 10, so 60 newtons. So if you show from the surface, so F normal is bigger, so 60 newtons. Okay, so you're pushing two vectors in the same direction, force of gravity and applied force. To make it more realistic, we can make size for applied force a little bit smaller. So key idea, if you have two forces in the same direction, you add them together. Normal force equal and opposite. And then situation when you have force pulling up, so let's applied force is up, and let it will be the same 10 newtons. Okay, so force of gravity stays the same. So 50 newtons. So those two forces are in opposite direction. So one is up, one is down. Okay, force of gravity is bigger, so vector is longer. So force of reaction from the surface will be smaller. So it's equal and opposite to resultant force of those two. So 50 minus 10, 40. So normal force is 40 newtons. Just to show that if object is on horizontal surface and forces act on it, so normal force could be bigger or smaller than force of gravity. Okay, so if you push object onto some angle, okay, so let it will be angle 30 degrees because it's easier to find sine of 30 degrees. The opposite side. So, okay. So let it will be force 10 newtons, applied force. So force of gravity, let it will be the same, 50 newtons. So what will be normal force? So when you push down, horizontal and vertical components of applied force will be down and to the right. Okay, so we are not worried about horizontal component, only about vertical, because to get normal force, you need to get force of reaction from the surface. So if you have hypotenuse 10 newtons, so across this side of 10 newtons, you will have force equal half of 10, because sine of 30 degrees equal 1/2. So 5 newtons will be vertical component of applied force. So now you have two forces down. So angle 30 degrees. Okay, I'll make it nice. So angle is 30 degrees. So vertical component will be 5 newtons. So F in y direction from applied force. 5 newtons down. And this force is also down. So 5 plus 50 is 55 newtons force down. So force of reaction from the surface will be 55 degrees up. So Fn equal 55 degrees, 55 newtons. Okay, so angle is 30 degrees. Okay, so what if you pull object under 30 degrees up? Okay, so the same idea. So force of gravity is the same because mass of the object didn't change, 15 newtons. Okay, vertical component of applied force. So let applied force will be the same, 10 newtons, angle the same, 30 degrees. So vertical component of applied force in y direction will be 5 newtons up. We're not worried about horizontal component. So you have now two forces in opposite direction. So resultant will be 50 minus 10, 50 minus 5, 45 newtons up. So normal force will be 45 newtons in vertical direction. Okay, so all those situations basically relates to by finding normal force of the object. Now, if object will be moving horizontally, so it means you need to pay attention on horizontal component of the force. Okay, if object is moving on horizontal surface, so if you have applied force okay, 70 newtons, and force of friction, so it's force between two surfaces, 10 newtons. Okay, mass of the object is the same, but it will be object 5 kilograms. Okay, so let's show all forces that act on the object. So force of gravity, so it's mg. So 5 multiplied by 10, 50 newtons. Force of normal force is force of reaction from the surface up, equal and opposite to force of gravity, 50 newtons up. So F normal, 50 newtons. Okay, so object is speeding up, accelerates, right? So, and why it accelerates? Because forces are not balanced. Force to the right is bigger than force to the left. So how to get net force? So according to second Newton's law, if forces are not balanced, object will move with acceleration in direction of the larger force. So larger force is applied force to the right, it's 70 newtons. Smaller force of friction is to the left, 10 newtons. So F net equal to MA. And it's larger force minus smaller force. So applied force is 70. Applied force 70, force of friction 10. So when you subtract them, so 70 minus 10 gives you 60 newtons to the right, direction of the larger force. Okay, so if we have net force, we will be able to find acceleration. So using second Newton's law, so F net over mass gives you 60 over 5, 12 meters per second squared to the right. Okay, so it's like typical questions that you had in grade 11. So object is moving, how to get acceleration or how to get speed at the end of the path if you will have some more additional information. But here, just key concept. So how to make free body diagram on horizontal surface. Okay, when object is, okay, and I will mention when object is moving with constant speed. So then all forces will be equal and opposite. Okay, so situation when, okay, actually I will extend the next page. Okay, so if object moves with constant speed, all forces are balanced. So let's make free body diagram. So force down and force up are equal and opposite, and force to the left and to the right also equal and opposite. Okay, so it means we are not ignoring friction. So applied force equal to force of friction. So it means speed is constant. So object will be moving with constant speed. If you don't have force of friction and forces are equal, it means it will stay at rest. Okay, so object moves with constant speed. Then in grade 12, you learned about circular motion. So when object is rotating on vertical circle, so which forces act on the object? So you have force of gravity and you have centripetal force. Okay, they're not equal to each other, and because they're not balanced, object will move under acceleration. So centripetal acceleration, like v squared over r. Okay, so object on the bottom, so force of gravity down, centripetal force up. The difference gives you ma. Okay, so ma net force equal centripetal force minus force of gravity. Okay, when object is on the top, so you have force of gravity down and centripetal force is down. Okay, so they're both in the same direction, centripetal. So net force will be sum of those two forces because it's a resultant force. So ma net force equal force of gravity plus centripetal force. And then you can separate actually factor mass, and you will be able to find what is acceleration. Okay. Centripetal force is v squared over r. Okay, and then you can cancel masses and write what is acceleration. So acceleration on the top, bigger. Acceleration on the bottom, smaller. Okay, or yeah, typical questions actually how to get force of tension, because force of tension is towards to the center of the object, and the force of tension will be bigger on the bottom. So if object will be able to get off the rope, for example, the rope will be broken, it's on the bottom, tension will be bigger. So centripetal, it's really force of tension. Okay, so we can write force of tension, and here force of tension. Tension. Okay, so how to rearrange, because most of the time we check what is force of tension there. So force of tension will be ma plus force of gravity, and force of gravity is mg. So ma plus mg. That's why it's very big force of tension. So rope could break. A plus g. Okay, on the top. Okay, so if you want to find force of tension, okay, let's rearrange it. Let's find force of tension. Okay, so move force of gravity to other side. So ma minus force of gravity. Okay, force of gravity is mg. You factor m outside. So a minus g. Okay, so tension is smaller because you subtract. And on the bottom, tension is bigger. So you add a plus g. Okay, then we have inclined plane. So grade 12. So inclined plane. So usually when you make a sketch, you need to have angle not equal to each other, like not 45, 45. So one is bigger, one is much smaller. So it's easier to see direction of all forces. Okay, object is on inclined plane. So here, let's fill the object. So to show forces, you make vertical line. So force of gravity is there. Normal is here. How to make normal? So it's perpendicular to the inclined plane. Okay, so 90 degrees angle between them. So that little triangle and this triangle equal, like similar to each other. So angles are the same. And here you have 90 degrees. So it's very important to make proper size and proper direction. Okay, so to show force of gravity, it's better to show force of gravity right near the end of the vector. Okay, so here is your force of gravity. Okay, here your normal force. Just for a second, I will check if we have more students joining on Ihala. Okay, just I will stop sharing. I will be back to the screen. Yeah, on Ihala. So Hala, you can hear me, right? Okay, you answered yes right now. Okay. Yes, yes, 130. Okay, good, good, good. Okay, I go back to screen because I'm just thinking, am I talking to myself or somebody there? Okay, so you can hear and see. Okay, so we have normal. So normal is perpendicular to inclined plane. Size for components of force of gravity. Okay, so FG in y direction is here. FG in y direction. So it's a vertical component of force of gravity, and here is horizontal component of force of gravity, FGX. Okay, so vertical components are equal. So normal force is equal and opposite to vertical component of force of gravity. So those two are equal and opposite. Okay, horizontal component. So we can show here on the surface. So because of horizontal component of force of gravity, FGX, object could start sliding if it's not very big friction. Okay, so if big friction, so if friction, for example, force of friction is bigger than horizontal component of force of gravity, object still will be at rest. Okay, but if friction is very small, you can make it smaller, object will slow down. Okay, or object will speed up. So here, small force of friction. Okay, so object will go in direction of the larger force. So if force of friction very small, so FGX, horizontal component of force of gravity, is bigger. So object will start sliding down with acceleration. And then we'll write MA, so it's net force, equal bigger force, FGX, minus smaller force, Fx. Okay, and most of the time you need to find maybe acceleration or what is force of friction, or what is coefficient of friction. But key idea, you start with making picture and showing that bigger force minus smaller force makes object to accelerate. Okay, so if question will be what is, how big is normal force, so you will need to calculate what is FGY. So what is FGY? It's adjacent side in right angle triangle. Okay, so if you need to get FGY, so it's adjacent. So hypotenuse FGX, FG, so hypotenuse FG multiplied by cosine of the angle, that angle theta, and this angle is the same as angle here. So cosine of angle theta. So force of gravity is mg, cosine of the angle, usually angle is given, and you can get what is vertical component, and it's equal and opposite to normal force. So if you need to find normal force, you apply this formula. Okay, so we had horizontal circles, inclined plane. Okay, so classical problem was in grade 11 about vertical motion when you have elevator problem. Okay, elevator problem. So when we had elevator and you had some forces acting on it, you need to find out what is the acceleration of the object. Okay, so if you have force of tension bigger than force of gravity, there is imbalance. So resultant force, F net, will be in direction of the larger force. Fix it straight. Okay, so F net equal to MA. And it's bigger force of tension minus force of gravity. And F net equal to MA. So if you need to get acceleration, you divide by, okay, force of tension minus force of gravity, divide by mass. If object is moving in direction down, okay, so if force down, force of gravity and force of tension is smaller, so object is spinning up down, acceleration down. So it means bigger force minus smaller force equal to ma. Okay, so the same way. So F net equal force of gravity minus force of tension. So if you need to get acceleration, both sides divide by mass. And in grade 11, it was classical problems pulley, horizontal, vertical pulley. And vertical pulley is also, we call Atwood machine. So you basically look on each object, write second Newton's law for each object, and then find resultant force. Okay, so I will attach this. Okay, I will attach this document to chat. Okay, so insert. Okay, I will save it now, and I will attach to the bottom. Okay, is it shared? I think I was sharing. Oh, sorry, I wasn't sharing. Okay, so what I wrote here, I will attach now to the chat. Okay. Yeah, so again, quick review. So on horizontal surface, if you're not pushing pulling object, normal and force of gravity force equal and opposite. If you are pushing down with applied force 10 newtons, so force of gravity stay the same, but normal force will become bigger because two forces in the same direction, applied force and force of gravity, we add them together. So normal force will be bigger, 60 newtons. If you're pulling object up, so force of gravity and applied force are in opposite direction. So their difference makes object to react, right? So normal force will be smaller. So 50 minus 10 gives you 40 newtons. So it depends from direction of applied force. So normal force could be bigger or smaller than force of gravity. And then I was showing example with elevator problems. So it's not on the surface, it's object that is hanging. So you have force of gravity and force of tension. So force of tension is bigger than force of gravity. It means object was speeding up. So difference between two forces, bigger and smaller, makes object to speed up. How to get acceleration? So net force divided by mass, because net force equal to ma. And similar idea for object that moves down with acceleration. So force of gravity bigger than force of tension. How to get acceleration? So net force divided by mass. Okay, on horizontal surface, if object is pushed by applied force under the angle, so normal force will be smaller. Okay, how to get normal force? You find in right angle triangle how big is opposite side. So in that right angle triangle, so applied force was hypotenuse, angle 30 degrees. So vertical component of the force is far away, we call it opposite. So opposite and hypotenuse are related through sine. So sine of 30 degrees equal opposite over hypotenuse. So we can find that opposite side will be hypotenuse multiplied by sine of 30. So it's 5 newtons. Or you can just memorize that side that is across of angle 30 degrees equal half of hypotenuse. Because sine of 30 degrees is 1/2. So 10 divided by 2, 5 newtons. So shortcut how to get it faster. So two forces down, force of gravity, 50 newtons, because we have the same object, we keep the same mass, 5 kilograms. So force of gravity is down. Normal force will be equal and opposite to two forces down. And we have applied force, vertical component down. So 5 newtons and 50 newtons together make 55. So normal force will be 55 newtons. So object is not moving in vertical direction. It's on the surface. And opposite situation, if you are pulling object under 30 degrees with force applied 10 newtons, we find what is opposite side. So horizontal component of applied force is to the right, and we don't care about it. We only worried about vertical force because we are trying to find what is net force, what is normal force. Okay, so vertical component of applied force is 5 newtons. So the same way, if you look at right angle triangle, you need to get opposite side, you have hypotenuse. So hypotenuse multiplied by sine of 30 gives you the vertical length. Okay, so two forces in opposite direction. So 50 down, 5 up. So resultant force is difference between 50 and 5 will be 45 newtons. So normal force is 45 newtons. Okay, so, and here reminder from grade 11. So if object is moving on horizontal surface with friction, how to get acceleration? Okay, so vertical forces equal and opposite, so they will not affect horizontal motion. So we just mark that you have 4 forces acting on the object, but we deal with horizontal components. So applied force is bigger to the right and horizontal force of friction to the left. So when you subtract them, you will get net force, because net force is resultant force. So bigger minus smaller, 70 minus 10 gives you 16 newtons to the right. So how to get acceleration? So by second Newton's law, why we have acceleration? Because forces are not balanced. So net force, we divide by mass, it gives us 12 meters per second squared in direction of the larger force, so to the right. Okay, and if two forces equal and opposite, applied force equal to force of friction, then according to first Newton's law, so there is no acceleration because forces are balanced. So object moves with constant speed. Okay, and then two situations from grade 12. So you have vertical circle. So when object is moving in vertical circle, so forces that act on the object on the bottom are force of gravity down and centripetal force or force of tension up. Okay, so we can put force of tension. And they're not equal to each other. So one is bigger, one is smaller. That's why object is speeding up, right? So bigger force minus smaller force, so force of tension minus force of gravity gives you net force ma. For situation when object is up, force of tension is down, it's along the rope towards to the center of the circle. Force of gravity is down because force of gravity always towards to the ground. So two forces are in the same direction, so net force will be sum of those two forces. So typical questions usually how to get acceleration or how to get force of tension. So basically when you rearrange that equation, so first to second, so top one, so position on the top, force of tension will be difference between net force ma and force of gravity. So force of gravity is mass multiplied by acceleration of free fall. If you factor mass out, it will be acceleration minus g inside of the brackets. For second one, so force of tension, when you rearrange, equal sum of net force and force of gravity. So when you rewrite what is force of gravity, it's mass multiplied acceleration free fall, and factor mass, you'll have inside of the brackets a plus g. Okay, so when we compare it, what we see, the tension on the bottom is bigger. So we have plus sign between those two terms. So tension is bigger, so chances that object will be removed from the rope will be broken are very high. Okay, so if it will be very big speed, so it could be bigger tension, so object could be flying off. because rope will be broken. And on the top, acceleration is okay, so acceleration, so force of tension will be smaller because inside of the brackets is difference between acceleration and G. Okay, so for inclined plane, what I was mentioning, that when you show forces act on the object, so force of gravity down, then you make normal. So normal is line that is perpendicular to inclined plane. Okay, so we can resolve horizontal, interhorizontal and vertical components force of gravity. So we make right angle triangle, so make perpendicular to normal. So this component of force of gravity is FGX. So it's perpendicular to normal. FGY is along the normal, and normal force will be equal and opposite to vertical component of force of gravity. So those two are equal to each other components. Okay, so if object is on very smooth surface in horizontal direction, it will be only horizontal component of force of gravity, so FGX, and object will be sliding down. It will be net force equal to horizontal component of force of gravity. If there is friction, we can show that if it's smaller than FGX, it will be imbalanced forces. So bigger force minus smaller force gives you net force MA. So you subtract them, and you can find whatever they will ask, maybe acceleration, maybe force of friction, maybe coefficient of friction. So if force of friction is bigger than FGX, then object will be at rest.